Hey guys, so today we're going to be looking at Rutherford and the discovery of the nucleus. When we left off, we had established Thomson's plum pudding model for the atom. And in Thomson's plum pudding model, we expected to see small negative charges embedded in a matrix of positivity. Rutherford comes along in 1911 to do this experiment. So if you're following along with us, this was like right at the turn of the century, very early 1900s here. 1909 is when Millikan comes out with his discovery. The plum pudding model is pretty much fact for those, couple of years. And now Rutherford wants to confirm this good idea that he believes Thomson had. So he looks at Thomson and Millikan's work. He thinks that this is a great idea, and he's going to use some radioactive positive particles in order to hopefully confirm and prove and provide support for the plum pudding model. Don't forget, the plum pudding model is false, so don't be surprised if he can't prove that it's true. Okay, spoiler alert. All right, so we're going to look at what he did in 1911. So we're going to go ahead, I'm going to go ahead and draw the gold foil experiment for you on the board. I'd love for you to draw it along with me at your houses. So what Rutherford does is he sets up a box that emits positive alpha particles. An alpha particle is a particle of radiation. So he has this box, and it's going to emit or shoot out of it like a beam. Think of it like a little laser beam of alpha particles. And I'm going to put little plus signs for a bit here as we make the beam of these alpha particles that he's shooting out. And he shoots them out at a piece of gold foil. So if you have aluminum foil in your house, you know how thin it is. If you've ever watched a baking show where they put like gold leaf on cupcakes, this is gold that you can ingest because it's so small, you don't even really notice it. That's the idea of the gold foil. The gold foil is meant to be so tiny that all you see, that it's really just like one atom in thickness. Now, it's not exactly true, but you're looking at it to be as close to one atom in thickness as possible. Really, really thin. The next component of this experiment is a detector screen. This screen, you can think of like a film, is going to detect any radiation that comes into contact with it. So this is kind of the setup for the experiment. Rutherford is going to bombard or shoot these alpha particles. He's going to shoot these alpha particles out of this box, past the entrance to the detector screen, through the gold foil, and he's going to see what happens. If the plum pudding model is true, the plum pudding model is shown up here in this red sphere. Remember our chocolate chip cookie model, where every part has chocolate chip cookies and dough. We would expect all of our positively charged alpha particles to pass through the plum pudding model of the atom unimpeded, with no forces of attraction, repulsion, deflection, reflection, none of that stuff would we expect to have happen. So if we were to pass positive particles through a plum pudding atom, they should all go straight through. So what they predict, what Rutherford, who works with Geiger and Marsden, who are experts in alpha particles, what they all expect to have happen is to have all of these particles come through and hit the detector screen right straight through at the back. So what is expected is to have 100% of the alpha particles go straight through, no problem, okay? This would tell us, this would support the plum pudding model. So this would give support to the plum pudding model if 100% of my particles went through. They set up the experiment, they turn on the machine, they get the results, and the results are not what they expected. So what they see, I'm gonna change my color to be purple, and then I'm gonna show you what they really saw. So the blue results here were the expected results, okay? In actual truth, we're gonna use really subjective words here, okay, subjective words. So we're gonna say most did come straight through as expected. But many, not just a few, some, many, so most did go this way. Some were deflected as they passed through the gold. And a few, a very small number, but a significant number, were actually reflected back. This shows the plum pudding model to be false. These results show the plum pudding model to be false. So Rutherford came up with some really good new explanations for what we might see or how these results might be possible. So what Rutherford describes is an atom like you're looking at right here on the page. We see the nucleus in the center and this green sphere of electron cloud. And so what he says is happening is as the particles pass through the electron cloud, if they go through just the cloud, they go straight through. And so that's the most that we see here. These ones went through the cloud. So these most end up going through the cloud. But the some, these ones came near the nucleus. They got close to the nucleus, so near to the nucleus, the positive nucleus started to push the positive alpha particles away and change their path. These ones got near positive nucleus, where the protons he's going to describe are going to be. These few are the unlucky few. These few happened to run dead center into the positive nucleus. Very small chance of that happening. However, a few, a small number, did. They actually ran into the nucleus. They ran into the nucleus, and that nucleus deflected them back towards the front of the gold foil. At the end of this, Rutherford comes up with a new model for the atom. Unlike Democritus' indivisible atom, in which case all of the particles would have been deflected back. Unlike Thomson's plum pudding model, in which all of the particles would have gone straight through. Now we have a new model for the atom in which the positive charges are kept in a small, densely positive region, which Rutherford calls the nucleus, and the electrons are spread throughout a larger space, and they're not nearly as dense, allowing for a lot of empty space for the alpha particles to pass through. This basic structure is true. However, Rutherford did conclude that electrons revolved around the nucleus like the planets around the sun. And we're going to find in a big chapter number 5 when we get there that that idea is not 100% correct. At the end of all of this work from all of these scientists, and we've only named a few, Democritus, the philosopher, we have Thomson and his cathode ray, we have Millikan with his oil drop experiment, and now Rutherford with the gold foil experiment. But each one of these scientists, of course, stands on the shoulders of the scientists that came before them. At the end of all of this work, we have calculated that the mass of a proton is 1,836 times larger than the electron. So we said the electron was a small portion of the atom and a big portion had to be the proton, and that has been confirmed. But the proton and the electron have equal but opposite charges. So a 1 plus proton and a 1 minus electron cancel each other out in terms of their electrical charge, but the proton is 1,836 times larger than the size of the electron. So before we leave off today, we're just going to finish the picture that we have so far, what we know about the atoms and their different models. So when we left off talking about our different models, we had gone through Democritus and his idea of the indivisible atom cannot be broken down. But the cathode ray experiments confirmed that there were in fact small negative particles inside of the atom, which left room for the idea that large positive particles, which we now know are the protons, were also present in the atom, leading to Thomson's plum pudding, or we like to think of it as the chocolate chip cookie model, with small negative spheres in a larger positive matrix. That model was tested and proven false by Rutherford with his gold foil experiment. So as far as we're going to take our model of the atom here in this chapter, remember in chapter 5 we're going to expand it, but as far as we're going to take it in chapter 5, we're going to leave it with this dense positive center, which we call the nucleus. And then we're going to have an electron cloud. And as the way that Rutherford described it, these would be electrons like kind of in orbit around the outside. And so this is Rutherford's clear model that has the nucleus on the inside. Moving forward, we're going to look at what we know about the atom and how we can differentiate them from one another. We're going to do some accounting, not really math, not until the very end of the chapter, but a lot of literal counting. How many protons, how many neutrons, how many electrons, what's an isotope? We're going to be going through a lot of terminology to help us to understand the atom as a whole.